Okay, so 20, we want to calculate the standard deviation and the variance. Now, let's remember that the variance is just the square of the standard deviation. So if you get your standard deviation using Excel, or if you do it the hard way, using the entire process, then all we have to do is square our answer to get the variance. All right, but let's just go ahead and use Excel here. So I'm gonna see, sometimes it's a little hard to copy these out of my open math. And if you have that, you might have to type it into Excel, but we're going to try to copy it. So let's go over here. I'll go right over here and I'm going to use my little clipboard to paste. And yep, and there it is. Okay, so now we'll just hit equal stand dot s, and we are going to highlight that whole amount right there. And you'll notice it sort of puts the cell numbers in there for us. Into that and hit enter, and there's our standard deviation. And then all we've got to do to get the variance is just square that. There's our variance. Okay, so that's really not a bad problem. Now, if you do it by hand, of course, it's quite a bit uglier than that. Okay, so let's go back to, let's see, the next one was 24. Okay, so same idea there. Let me mention, I'll just go back to that other one because you can do the mean very quickly as well. But in Excel, you're going to use average. So you just do equal average parenthesis. Don't forget the parenthesis because it's very important. We just highlight what we want it to do the mean of, close the parenthesis, and there's our mean. Okay, so those two should be much quicker for you now. And of course, you can do the standard deviation. Now, population standard deviation, the only difference is going to be equal. Oops. Stan dev, see the P for population. Oops, except I goofed there. There we go. Close it. And it's slightly different, and it should be slightly different. So we can get those rather quickly. Let's see. 30. This thing is just driving me crazy. A company has a policy of retiring company cars. This policy looks at number of miles driven, purpose of trip, style of car, and other features. The distribution of the number of months in service for the fleet of cars is bell-shaped, so it's normal. It has a mean of 47, so we'll write that down. We have a mean of 47, a standard deviation of 10. Using the 68, 95, 99.7 rule. So using our empirical rule, what is the approximate percentage of cars that remain in service between 17 and 37 months? Okay, so let's go back to my Word document because we're going to draw a picture. And I might want to pull up another one here. And when we see the empirical rule in use, we want to draw a picture of our normal curve. And again, probably a pretty ugly drawing on here, almost like a little first grader. Hopefully a little bit better than a first grader. But we're going to put our mean in the center of that normal curve. So our mean was 47, and our standard deviation was 10. So one standard deviation away to the left, we'll just subtract 10 from 47. It's 37 over here. And one standard deviation to the right will be 10 more than 47. It'll be 57. So that right there is 68% of the data within one standard deviation of the mean. That's what our empirical rule says. So we know that right there is 68%. Or we could just say this is, in terms of probability, it's 0.68. between there and there. We could even say this part right here is half of 68 because each of these are symmetric, although my drawing is certainly not perfect. So half of 0.68 would be 0.34 right here, and also 0.34 right here. All right, now let's keep going because we still haven't found 17 to 37. We got the 37 there, but not the 17. So let's go 2 standard deviations away by subtracting another 10. So this will be 27. And over here will be add another 10, 67. Now that's 2 standard deviations away. And remember, the empirical rule said that this is 95%. So 95% of the data is between those two values. Okay, now what we can do here is sort of break this down a little bit. We know there's 68% in between here and here. So if we do 95 minus 68, 95 minus 68 is 27. So this is symmetric. So 27 is the percentage that's in these two areas right here. Since they're symmetric, let's divide by 2, and that will tell us how much is in just one of them. So 13.5% is in each one of them, or as a probability, 13.5% would be 135.135. And the truth is, I don't really need these right-hand ones because we're going to be looking between 17 and 37. Okay, so now let's go out one more standard deviation. So if we subtract 10 from 27, there's our 17. And if we add 10, there's 77 over there. Okay, now 3 standard deviations from the mean. Our empirical rule says that 99.7% of the data fall between these values right here. Okay, now let's do kind of the same thing that we did with the 95%. We are going to figure out how much of a probability is right here. And since it's symmetric, let's take our 99.7 and subtract our 95, and that'll tell us what's left over for these two pieces right here. So 99.7 minus 95 is 4.7. Now, if I divide 4.7 into 2 equal parts, that'll tell me what percentage each of these is. So 4.7 divided by 2 is 2.35, or really as a probability, that's 0.0235. And we could write it on the right side over there as well, but I'm not going to because we don't need it. Because we want to know what's the probability between 17 and, was it 37? Yes, 17 and 37. So let's notice from 17 to 27, the probability is 0.0235. So we will take that. And let's add that to the probability from 27 to 37, which was 0.135. And that will give us the final probability between 17 and 37. So when is that 0.1585, I believe, if I added correctly there, since I didn't stick that in my calculator. And that has that one. Okay, so let's see. I think we had one more to look at for you, number 31. So let me go pop back. Okay, so let X represent the full height of a certain species of tree. We want to assume that it's normally distributed with a mean of 225.5 feet and a standard deviation of 7.5 feet. And, darn thing, we want to find the probability that the height of a randomly selected tree is as tall as mine or shorter. So really we're finding less than, which is good because when we plug less than into our Excel, whatever probability we get out is our answer. Okay, but first, before we can plug anything to Excel, we need to go ahead and do our z-score formula. All right, so we're looking for the probability that x is less than 234.5. Let's go back to Word and we'll do the z-score formula and then we'll plug it in to Excel. All right, so z. So we're using this formula and we wanted to find the probability that x was less than 234.5. So our x is 234.5. Our mean was 225.5. I know that doesn't look like a 2. And our standard deviation was 7.5. So do the top first. 234.5. 225.5. So the top is actually 9. Let's divide that out. And that gives us a z-score of 1.2. Let's look it up. Now remember that we were looking for the probability that x was less than 234.5. So when we look up the value in Excel, that will be our answer. Okay, so let's go to our Excel and we will type equal norm.s.dist. We'll put in, oh good gosh darn it, what was it? 1.2. And true. And that's the answer. That is our actual probability, 0.88493. Now, I think our next one is greater than. We're going to do the same process for greater than, but at the very end, whatever probability we get off of this chart, we have to subtract it from 1 because this gives us less than, not greater than. Okay, so let's go to that. Hopefully I can get it in before I run out of time on here. Oops. All right, so we want the probability that x is greater than 242. So again, let's go ahead and use our z-score formula. Let me go back over here and let's stop that for a second to move this up. This time though, for x, I'm going to put 242 in minus 225.5 over 7.5. That's 16.5 over 7.5. That one I probably ought to listen to. That gives us 2.2. Let's look that up on Excel, but we are going to subtract whatever we get from 1. So going back here real quickly before I run out of time. So I want equal norm.s.dist 2.2, true. And it's 0.986097, and we'll just do it right here in Excel. Let's subtract that darn thing from 1, and then we will have the actual probability is that. All right, so that hopefully answers those questions for you, which is right in time because I'm running out of time on the video.